Good afternoon or good evening, wherever you are in the world. My name is David Newman. I'm the Managing Director of the BBIA here in London. And with great pleasure, I welcome you to this webinar, which has been sponsored by the TICO Corporation around the Breaking the Plastic Wave report, which SYSTEMIQ wrote for the Pew Charitable Trust and published this last July. I'm delighted to be joined by two of the authors of the report, Yoni Sheeran and Julia Koskela, who are going to present it, and with Julia Shifter from TICO Corporation, who is going to talk about one aspect of the report, which is the use of compostable materials in helping to break the plastic wave. Now, why is this report important? It's important because it sets out in a very systemic, and excuse the pun, a very systemic fashion, all the various pathways that we need to take to reduce the amount of plastics which are going into the environment. And Yoni will be talking more specifically about those pathways and the role that compostables can play in contributing to that. And this is where Julia Koskela will come in. It's a very long report. And one of the benefits of seeing a 1-hour webinar is that you can get a synthesis of it from the speakers themselves without having to read the whole report. But for policymakers around the world, wherever you are, I really do recommend you read it and you study it in some detail. It is a very comprehensive guide to how we have to tackle the phenomenal problem we've got of plastic waste. Now, you're all experts on Zoom and you know how it works. So there is a question and answer button down at the bottom. If you wish to ask questions to the speakers, send those through on the Q&A button. When they have finished their initial presentations, I will shoot one or two of the questions at them. Then when they all three have finished, I will bring them back to the panel and shoot as many of the others as I possibly can. That's enough from me. Welcome, Yoni, and welcome, Julia. And the floor is yours.
Thank you. Thank you, David. It's really wonderful to be here. And I'm sure that everybody has actually read every single page of the report. But just in case somebody missed one page, I'm going to give you a quick summary of the overview. Hi, everyone. My name is Yoni. I'm based in London, and it's really wonderful to be here today to talk about breaking the plastic wave. This project has been an absolute baby of mine for the last 2.5 years. So I'm delighted to be sharing with you all some of our findings. You know, today we'll talk a lot about numbers and statistics and things like that. But I do want to start with what I think is quite important, which is the people element and the people story behind the plastic crisis. For me, it all started in my first journey to Indonesia. I remember going to a beach covered in plastic as far as the eye can see. I remember children playing on plastic, maybe 80 centimeters high, probably not even aware that there is sand underneath. Many of you have been there and know exactly what I'm talking about. The awful sights, the smell of decay, the difficult conversations in the homes of the local village people. It's really an out of this world experience. And at that point, you realize how far we have departed from nature's most basic design principles and how we must change the system. And when I first realized that we actually have the technologies today to address 80% of the plastic going into the ocean, it was very motivating. And it's not something that we could do in 50 years or 100 years. This is something that could be done within our lifetimes. By the time that my baby daughter is 20 years old, plastic pollution could be a thing of the past. That for me was a eureka moment, and I'm really happy to be sharing it with you all today. So when we started, kind of why did we start? Why did we do this work? I guess when we started, we were looking at the plastic conversation, which was obviously very active with many, many stakeholders, but it felt like there were 5 broadly unreconciled propositions. Some people were saying we should just ban plastics altogether. Some people were saying we should burn or bury plastic. Some people were saying we can just clean up after the fact. Some people were saying we can recycle plastic and that we can build a recycling industry as large as the plastic industry. And some people were saying that we can rely on bio solutions. Now, what occurred to us is that it wasn't very clear how these strategies perform on different environmental, economic, and social indicators. What are the costs or investments that are required? Which geographies and materials do different solutions apply to? And what is the timeline? So there's many, many questions, and decisions were being made as all these questions were unanswered. So it felt to us that a strong fact-based database on these questions was due. And while the world was debating, the plastic kept rising and rising. So it's definitely an urgent matter. I'm happy to say that our work has been published in Science in July, and a few weeks ago, we were actually featured in the cover of Science, which was obviously great for us, not least because it gives us the credibility that we need. This is obviously a very complex topic, a very complex system with many, many viewpoints. So having an independently peer-reviewed analysis was important for us if we are to contribute at all to this debate and to this conversation. So today I'm going to walk you through the four main questions that we're trying to answer in the work, which is, where are we headed? What's the way out? What will it cost? And what's the prize? Let's start with, where are we headed? In short, not to a great place, as you can imagine. Business as usual indicators are gruesome. Specifically, when we look at municipal solid waste plastic globally, we're talking about a doubling of production in the next 20 years, a tripling of plastic leakage to the ocean and to the environment broadly, and a quadrupling of plastic stock in the ocean. So 2x, 3x, 4x. This is definitely a future that none of us wants. Just to put that in context, 29 million tons of plastic going to the ocean every year is equivalent to 50 kilograms for every meter of shoreline in the world every year. So these are numbers that are just hard for us to comprehend. This is the scale of the challenge that we're up against. When we look at what is being done so far, obviously many governments and companies and lots of innovation are committing to, many programs and initiatives are committing to do something about this challenge. Based on our analysis, when we quantify all of those commitments put together by governments and by the companies, we see that only making a 7% dent on the issue. So definitely kind of has an impact, but definitely not enough. We definitely need to increase the urgency, the ambition level, the solutions, the policies, and we need to do that with urgency. When we take when we look at the BAU from a purely financial perspective, from the perspective of industry and specifically the big brands, we're saying that by 2040, the cost of waste management of plastic, just of the plastic of MSW, we estimate that to be $100 billion per year. To put that in context, that is 3 times the gross profit of that industry today. So if governments turned around tomorrow and said, dear industry, this is a cost that we are taking because this is an externality to your product, a cost that we are paying to deal with your product. Dear industry, can you please pay for this externality? Then the business model, the viability of the business model as we know it today, basically does not work. You can see that the cost of managing this waste is 3 times more than the profit that the industry is making out of it. So that's, in a nutshell, where are we headed? What's the way out? This is the million-dollar question or the billion-dollar question. First, what's not the solution? So we know that business as usual is not the solution. We just saw it has a 3x growth in leakage to the environment. Current commitments, not enough. We then modeled the number of scenarios, starting with the recycling scenario, which obviously many people are betting a lot on recycling. We asked ourselves, what happened if you implement recycling as ambitiously as you can possibly imagine, including scaling up collection, scaling up recycling, mechanical recycling, scaling up chemical recycling, scaling up design for recycling, doing everything we can think of for recycling and doing it on a global scale, how far will that take us? And what we found is that it has a big dent on leakage to the ocean, but it only flattens the curve. We definitely don't go down to near zero leakage as we would have liked. In other words, we cannot recycle our way out of the problem. I think many people have said that before, but we have, I think for the first time, quantified that statement and put numbers behind it. Next, we looked at reduction and substitution. What happens if we push reduction and substitution as possibly as we can imagine until we start hitting climate change constraints, economic constraints, consumer acceptance constraints, technical constraints. Again, we have a big dent, but we don't get down to zero. And then next, we looked at what happens if you scale collection and disposal globally, again, as far as you can possibly imagine it, including investing billions and billions of dollars into collection infrastructure globally and landfilling all that plastic. How far does that take us? Similar story, big dent, not down to zero. It was only the scenario, what we call the system change scenario, the one that combines upstream and downstream and puts all solutions together, is that we can have a meaningful reduction. We estimate over 80% reduction of plastic leakage relative to BAU by 2040. That is a scenario we like. That is a circular scenario, circular economy scenario. That is a scenario we like, and that is a scenario that we will focus on today in this presentation. So if you look at that green line, that just shows you the leakage to the ocean. But if you want to see what does the wider system look like, the plastic system under that scenario. So the bottom is the line we just saw, is the leakage to the ocean. Leakage to the ocean, of course, is a derivative of overall mismanaged waste. And under this scenario, mismanaged waste, kind of those red wedges are all shrinking. They don't get down to zero. We don't think that's possible with today's solution, but we do think that it can go down significantly. And then we ask, what does the rest of the system look like? So we have a reduction wedge. This is plastic that can be reduced out of the system. Many people before us have said that we need to get rid of unnecessary or avoidable plastic. We absolutely agree. We have, I think for the first time, quantified what is the potential of that with a very robust methodology, looking application by application, geography by geography. What is the potential of the different solutions that are out there if they scale? This was our conclusion. 30% of plastic by 2040, we think can be reduced. We next look at substitution, which of course is a big topic for today because it's where compostables fall under. We think that substitution has a potential of 17% of the plastic system. Again, we looked at different materials, we looked at different applications, different geographies, and asked ourselves which substitutes make sense where when we take into account LCAs, climate, costs, recyclability, compostability, and other factors. This was our conclusion, and Julia will take you into a bit more detail of this a bit later. Next, of course, we looked at recycling, a critical part of the system as well, which we estimate can be about 20%. And last is the one that we don't love, but we think that disposable or dispose is part of the portfolio. Unfortunately, none of us like the solution, but we think that some plastic cannot be reduced, cannot be substituted, cannot be recycled, at least not with known solutions today. And so we have to account for some dispose wedge. So this chart is what we call the wedges chart. It is basically our signature chart from the entire work. And one way to think about this is ultimately here we're talking about plastic utility. Is what customers really need, right? Because consumers don't need plastic, they need the services that plastic provide. They need food safety, they need containment, they need all the wonderful things that today we get from plastic. What we're saying is, how can we deliver that utility in ways that are smarter, that are better for the planet and for the people and for the economy? So essentially the reduced wedge at the top is ways to deliver utility in non-material ways. So here we don't need materials to deliver this utility. The substitute, the blue wedge, is utility that we deliver in non-plastic ways. The third, the green, recycling, is delivering utility in non-virgin plastic ways. And the last two, the yellow and the red, is utility that we deliver with virgin plastic. So you can see the share of virgin plastic goes from a very high share on the left, 2016, the yellow and red, almost the entire share of the utility, to a much smaller share by 2040. What will it cost? I'm sure you're all asking yourselves. So if you look at this picture one more time, if you take a thin sliver at 2040, which is the share of the solutions, and you turn that by 90 degrees, we now look at what is the cost of the different solutions. And what we see is that reduction is a net saving solution, so the cost is below zero. Recycling is in the money in some places, as you can see, but not everywhere. Disposal is a net cost solution, and substitution, at least today, is a bit more expensive than plastic. There are solutions, and we'll hear more from Julia from SYSTEMIQ and from Julia from TIPA, what can be done to make sure that these solutions are affordable. But as of today, to the best of our knowledge and to the best of our assessment, these are slightly more expensive than plastic. It doesn't have to be that way, but that is today. When you look at the overall system, what does that mean? So we're saying it's better for the economy because the cost to governments, the net cost to governments go down by 11%. It's better for the private sector because the net cost of providing this utility to consumers goes down. It's better for the environment because leakage goes down significantly. This is what we were solving for in this model. And it's even better for greenhouse gases, which also go down by 25%. Not nearly enough for what we need for Paris, but this is great news for us because when we started this project, we were asking, what is the trade-off between reducing plastic pollution and reducing climate emissions? And what we find is that there is no trade-off, and in fact, these things can go hand in hand and they can help each other. And then also better for communities and increasing employment. This shouldn't be a surprise to anyone. We all know that the circular economy is more labor intensive than a linear production economy that is more capital intensive. So especially in the era of COVID and especially in the crisis that we're going through now with the pandemic, a lot of people are asking, how can we build back better? Well, when I look at this scenario, when I look at this slide, it's better for the economy, better for the environment, better for communities. If this is not build back better, then I don't know what is. So especially in the context of COVID, I think it's especially important that we go after some of these solutions. To summarize, what's the prize? We talked a bit how the system change scenario can reduce plastic pollution in the environment, how it can reduce greenhouse gases, how it can reduce costs, how it can create employment. I want to take you back to the beach of Muncar in East Java, Indonesia for a second, where we ran a small project that cleaned just a few hundred meters of shoreline. And the children came back to the beach and they were playing in the sand, many for the first time in their life. And children were just being children again. And as a father, what that makes you realize is plastic pollution is not just taking away the tourism and the employment of their parents. Plastic pollution is also taking away their childhood. And if nothing else, hopefully this alone is enough reason for us all to act. Thank you. That was my summary of breaking the plastic wave. And now I will pass over to my colleague, Julia, who will dive a bit deeper into the substitution wedge and talk a bit more about compostables. Julia, over to you.
Thank you so much, Yoni. Thank you for that great introduction to the whole report. I'm now going to dive a bit more into the technical details of the substitution wedge in particular, and how we're thinking about compostables in this report. I would start by saying we took quite a balanced approach. We consulted many stakeholders, both in favor of compostables and people pointing out the obstacles. And today we'll run through both of those and how our report balanced both the opportunities and the challenges. Because to make this 2040 opportunity to substitute 1/6 of plastics is going to require a lot of work and getting the whole system to work together for substitutes. So there's definitely some challenges to overcome, as well as a great opportunity in certain applications for growing out compostables. On this slide, I'll start by walking you through a little bit of the methodology. So we took a very nuanced approach to come up with our number for the substitute wedge, and that looked at 140 different combinations of levers and specific use cases for plastic that we could have, and we scored every single lever combination for 15 different types of plastic, and looking even more nuanced than that. And then there was a scoring that helped us make sure we weren't modeling any solution taking place by 2040 that didn't meet 5 tests. So first, affordability. We looked at data today of how affordable these solutions are and how that would evolve. Performance, so we need to make sure that no solutions we roll out are going to increase food waste, and make sure that they have a positive sustainability performance. Number 3, technology. So is the technology available? We only modeled solutions that were at least getting out of labs, nothing that was just in concept phase. Convenience, so will consumers accept this? Do they have to take on massive lifestyle changes? And feasibility, political will, movement of direction of travel. So these were the tests we put to come up with these numbers. And that gave us results on by plastic category in terms of what can be substituted, what can be reduced, what can be recycled. So you'll see that plastic films here have a large substitute wedge. We did not model a substitute wedge for PET bottles because the performance of some of the substitutes we don't think is really there yet. So that gives you a snapshot of the level of detail and the kind of method we used to come up with these figures. Great, so looking more specifically at compostables here. So there's about 38 million tons of compostables in our scenario in 2040, the system change scenario around the world. We think that 38 million tons of plastic can switch to compostables. Now, 35 million of those tons of plastic that can be substituted by compostables come from just 5 key items. So we're bringing that up here so we can focus in on where we think these solutions are really positive. The huge one is stretch films and wraps. They make up a large proportion of waste, and we think that 25% of them could be switched by 2040 towards compostable alternatives. A quick note, when we say compostables, we don't only mean compostable plastics. These could also be compostable cellulose-based materials, plant-based materials, leaf-based materials, algae-based. So we took a very broad definition of compostable as materials that meet local composting standards in practice and at scale. So stretch films and wraps, a large opportunity there. Second, grocery and carrier bags for some applications where those plastic bags are unavoidable and can't be reused. We think compostables could come in there. And then things like secondary packaging, blister packs, cushioning. We use polystyrene, expanded polystyrene for a lot of those applications right now, or multi-materials. So it's important to think about alternatives to those that could be recycled or composted at end of life. So that's the picture of the wine bottle there in a mushroom-based foam material. And then, of course, any multi-layer films and sachets we can get out of. Great, we have a picture of a soup sachet that's made from an alginate material that can dissolve in water, and there's edible. Food service disposables, also a good place to focus in on. We see, of course, EU legislation coming in banning the plastic versions of food service disposables. So we see large growth happening in compostables in that area. These are also items that are very likely to end up in the environment. They have high littering rates, unfortunately. So thinking about how well things might do if they do end up in the environment is something we're thinking about. However, a key message of our report, as you'll see, is that no material is safe to litter at scale. So we really need to think about the end of life system adapting to these materials coming online, and not just putting them into the market and expecting that they'll be okay to end up in the environment. When we look at these types of categories, there's three things that people that make these categories attractive. So first, we're looking mostly at thin applications. The thinner the layer of compostable material, the more likely it will have a fast biodegradation timeline. Materials like PLA, we don't see being home compostable at all. You know, they need industrial composting infrastructure, and they're very thick, so we'll have a long time frame. So thin is the first kind of thing to look for. Also, materials that are likely to be in close contact with food contamination and things that will be really wrapped up with the food, like coffee capsules or maybe salad bags that are often thrown away with the malted salad inside, seeing how we can combine the organic waste stream with a compostable package around it. And then finally, items that are lacking plastic recyclability and collection and recycling infrastructure today. So i.e. a better solution within plastics is also not available. So those are some guidelines to help us think about narrowing in a focus on where compostables are most relevant. On the next slide, thanks Yoni, we look at geographic breakdown. So where is this compostable wedge coming to life in our report? Where do we think that's going to take off? So we split the world into 4 different income categories. Here we've shown that a lot of the growth is coming from these middle and low income countries, and high income countries will have much less of the plastic by 2040. So in these high growth markets is where we see a lot of the opportunity for compostables. What is that, about 4 times as much potential as in high income countries, although we're seeing often the first movers are coming from high income countries. Not exclusively though. There's lots of amazing innovators and solutions being rolled out in the global south as well. And then let's look at this. Why is there such a large compostables wedge in middle and low income countries compared to paper? So there's partly a geographic aspect to that. The global south has more limited availability of paper and types of slow growing temperate trees that are right for making paper. So looking at faster growing kind of plant-based materials from compostables could be much more locally sourced and more sustainably sourced. So that's one thing, is looking at locally available materials and sustainable sourcing. Also kind of, you know, we definitely did not want to be destroying virgin forests to grow the paper wedge. So we looked at land use availability and that environmental performance test. So we think there could be some great opportunities in compostables there. If you look at sourcing from agricultural waste materials, if you look at sourcing from sustainably sourced produce and locally available materials. So that's some of the reasons why compostables is much larger in middle and low income countries. Also, we expect the cost of compostables will become more competitive over time. Paper is approximately 1.5 times more expensive per product, per packaging type to house things in right now for their packaging. Compostables is currently about 2x the price of plastic, but as we grow compostables, we think that's such an area of innovation that costs can come down. So there was a economic argument to kind of these low-income countries being able to afford some of those in the future, and paper perhaps again being a little less suited. Finally, there is an opportunity to where we're really lacking collection and recycling infrastructure in these global south countries, where even landfill space for landfills is really limited. We're looking at compostables as an option, having an end-of-life option where they could be locally treated. So decentralized, low-cost, compostable composting units, almost community-based. So if we can scale that and have materials coming into those markets that degrade very quickly and safely and don't need standard, high-spec industrial composting, we thought there could be an interesting opportunity there. Thanks. So that's kind of the opportunity of where we might lean in as innovators in this compostable wedge by geography and by the plastic types and product types we could replace. Now, let's be honest about some of the challenges. The solutions for compostables are not all there today. There are a lot of critics of compostables playing a large role, so we need to take these issues very seriously and sit everyone around the table as a system to drive forward an end-to-end solution for compostables that really works. 4 key challenges. So the first is we need to achieve composting of packaging in practice and at scale. Today, the compostable packages entering the market are usually rejected by composters if they get collected at all. Europe is seeing a large upswing in and a mandate that they have to collect organic waste, so there's an opportunity to have a lot higher collection rates in the household for compostable material, but it's yet to be seen whether compostable packaging will be accepted in that. So collection and being able to process it, really important. There's also a mismatch between standards where some materials can achieve compostable labels that because they can degrade in a composting unit in a matter of months. But composting, most composters, when you speak to them, want things to degrade in a matter of weeks, so they will reject those materials. So we need things to be composted in practice and at scale, and material types and end-of-life types to both meet. Second, we need some policy drivers, legislation helping balance the benefits and costs between plastics and compostables a little more. Things like fossil fuel subsidies, maybe disrupting this market. And as we see compostables innovate, we want to see cost coming down over time. Number 3, supply chain innovations. So there's a large story here on how we can make compostable materials compatible with supply chains. Supply chains could shorten so that we don't need as much shelf life, and we don't need an oxygen barrier that will last for 2 years. You know, some compostable materials can create an oxygen barrier for only 6 months. So maybe we could shorten supply chains or increase the barrier properties of compostable materials. So thinking along those lines. And then finally, sustainable sourcing and balancing life cycle emissions. We think like full life cycle analyses that really take costs and benefits of plastic and their substitutes into account is super important, almost on a case-by-case basis, geography by geography. As rules of thumb, we're really excited to see agricultural waste and other waste sources being used as feedstock for compostables, because we see the production phase emissions of compostable products varying wildly depending on if it's sourced from fossil fuels or if the compostable plastic is sourced from corn oil or beetroot sugar. You know, all of these things change the picture dramatically. So it's important to take a detailed view. Lots more to be said, but I'll leave it there and happy to answer Q&A. Thank you so much.
Thank you, Yoni and Julia. You've raised a lot of issues and a lot of questions, and I know there's questions coming in from the audience. I'm going to keep those for the panel after Julia Shifter has spoken. But I want to ask you, Yoni, and you, Julia, just a couple of quick questions. And Yoni, the first is you addressed the question of profitability. You know, if the externalities had to be paid, it would be 3 times more than the profits which are made from the sale of plastic today. But have you looked at the legal liability? And the legal liability in terms of the producers of plastics actually being taken to court, as the big oil companies are now being taken to court for climate change. Has that been a consideration that you've come across?
Yeah, for sure. We work on this in the system, as you can imagine, so we know these players quite well. There are many kind of legal battles in many parts of the world, mostly in the global north, a few examples in the US, a few examples in Europe. We expect, and I think everybody expects, these only to rise over time as there's more and more awareness to the cost or the price that society is paying for plastic and the externalities that come with it. So there's definitely a legal cost. We haven't quantified it yet because it's not robust enough. We focused on, you know, what is the techno-economic cost of collection and waste management, which is more robust. But there's definitely a legal price that is coming with it as well. And not to mention a reputational price that all these companies are feeling the heat. not just from their customers and consumers, but also from shareholders. A lot of pressure coming from investors, a lot of pressure from employees of these companies, right? So definitely many types of pressures.
Yeah, thank you. I sort of feel sorry for young people today. You say to them, you know, what do you want to do? You can't answer like the graduate, go into the plastics industry. It's a bit like saying, you know, I want to make nuclear bombs today for young people. And it shouldn't necessarily be like that. Another quick couple of questions for the two of you. Take them as you wish. The thing around chemical recycling, we hear a lot of noise and we see a lot of investments, particularly by the petrol companies, Savage and so on, into chemical recycling. Any idea how far away that is before it comes to scale? First question. And secondly, I was very pleased to see you busting the myth around greenhouse gases. You know, a lot of the argument around the use of plastic packaging is, oh, we will get more greenhouse gases if we use less plastic, and everything will cost more greenhouse gas than plastic does. A couple of comments on those 2 points, please.
Yeah, I'm happy to take the first question on chemical recycling, Julian, then you can complement and maybe take the second part. Chemical recycling, obviously a massively controversial topic. I'm sure everyone in the audience is aware. If you talk to 5 people, you'll get 6 opinions on chemical recycling, right? Our perspective, as everything in this report, we try to be quite balanced, and we try to look as objectively as possible at the pros and cons of each solution, and trading off the different things that we're trying to solve for, and the challenges that we have. Our view on chemical recycling is that it does have a role as part of the plastic crisis. But having said that, we think that the role of chemical recycling is much more, is not as large, let's say, as many in the industry are suggesting. So our conclusion is that chemical recycling, plastic to plastic chemical recycling, can be roughly 13, that's 13 million tons by 2040, and we use the number of techniques to come up with that number. I'm happy to go into detail offline, but that's our kind of estimate of the size of that. And then you asked the question of how quickly is that. We're seeing many plants at pilot level today, and many commissioned plants, so we expect it to start scaling quite quickly, pretty much starting now. Having said that, the majority of the capacity today is plastic to fuel. That we do not, that is not very different from incineration, because you're basically burning plastic for the fuel, for the energy. You're giving it maybe one more loop, but it's definitely not a circular solution. It's definitely not a recycling solution, at least not in my books. That's the majority of chemical recycling we see today. Hopefully over time that industry shifts from plastic to fuel, plastic to plastic, but that has a number of challenges and hurdles it needs to pass, which we'll go into now, because today we're focusing on compostables, but we could give a similar presentation on chemical recycling. Hopefully that answers your question. Julia, anything to add there?
Thank you.
I think that's covered from the chemical recycling side. I can take the greenhouse gas emissions comparison question. The answer, of course, is it depends. We tried to look for the best peer-reviewed studies we could find, the most neutral studies, to come up with our estimates in our model of an average per ton emissions factor for substituting to paper and substituting to compostables. That came out as being slightly higher than plastic for compostables, and I can talk about that in a moment, and slightly lower to switch to paper. Those were the assumptions we used. Obviously, those are full of caveats. The paper in particular, to be lower greenhouse gas emissions, needs to be from sustainable forestry. The paper production process needs to be fueled by biomass and offcuts from the paper industry. Many caveats to achieving, and you can't kind of have a much higher weight of a paper package that's replacing a really low, lightweight plastic package. So many caveats to achieving GHG savings from a switch to paper, but that was the assumption in our report, if caveats are followed. With compostables, the evidence we saw today, there are examples of plenty of examples of compostable materials performing better. That really depends on having sustainable sourcing. However, on average, the studies we saw had compostables coming out at a little higher emissions per ton than plastic. I think that's because they're a new technology. We haven't achieved the production efficiencies we need to convert things like plant oils into sophisticated bioplastics, and many changes could be made there. Hopefully that answers your question.
Thank you both. Yeah, thank you both. Okay. I was interested that my epiphany, Yoni, with plastics was on a beach in Belize in 2006. I had exactly the same experience that you did. I was shocked. I just didn't realize what a mess we were in, and that was 15 years ago. So thank you both. Now we're going to give the floor to Julia Shifter, and she's going to deep dive into compostables, seen from the point of view of a producer and a distributor of compostables around the world, and look at the opportunities and where her markets for those are developing. Then we will come back to the panel with the loads of questions which are coming in on the Q&A now. Over to you, Julia.
Hi, good morning, everyone. So in this presentation, we'll try to focus on the role of flexibles or compostables packaging in the new plastic economy, specifically focusing on compostables, on flexible compostables. If you can move to the next slide, please. Sorry, I just... Okay. Oh, okay. If you can go back one slide. Yeah. Okay. So flexible packaging are predominantly used in the market today, and for a very good reason. Flexible packaging are not only extremely easy to use and convenient to end consumers, but they actually dramatically reduce the amount of plastic or material we need in order to package goods, and they also reduce our carbon footprint. But when we look at the end of life of flexibles plastic, then the picture quite dramatically changes. In a stark contrast to almost any other material we use in the market today to package goods, anywhere from glass, aluminium, paper, cardboard, monomaterial, rigid plastics, flexibles are not widely recycled. We can move to the next slide. Actually, only 4% of flexible plastics are recycled today in the UK, and the global numbers are even lower. The challenges to recycle flexibles are multiple and across the entire supply chain, anywhere from sorting centers being able to detect flexible plastics to the recycling technology being significantly challenged by treating these very thin layered materials and further challenged by multi-materials and food contamination, which ultimately leads to extremely limited secondary markets for flexible plastics. Next slide. If we broaden out the picture and look at both food waste collection and flexible plastic collection from households, then the picture is quite grim. Over 80% of food waste is today incinerated or landfilled, as opposed to being organically recycled, whereas 96% of flexibles, again, are incinerated or recycled. Next slide, please. How can we move forward from this reality into a better future where potentially new solutions can help, as the SYSTEMIQ report has given us? Next slide, please. Okay, so let's assume for a minute that we have resolved a lot of the challenges that we have today for compostables, for flexible plastics. Let's assume that now sorting centers can screen and detect flexibles with a cost which is currently unknown to us because we don't have that. Let's assume we've transferred the majority of multi-materials into monomaterials, again reducing significant obstacles to recycled plastics. And let's assume that we have built new recycling plants to actually treat flexibles, and the cost of doing that, based on CFlex estimations, would be approximately €500 million for the UK only. So let's assume we have done all of that. We are still faced with 81% of flexibles being food contaminated, therefore not being able to be further treated and be used for food packaging, whereby food contamination is actually a perfect fit for compostable packaging, helping further divert food scraps and nutrients that are otherwise have been lost. Other challenges like multi-materials or small formats are not a problem to composting facilities at all. And like Julia said, the thinner the solution, the easier and the faster it will degrade in compost facilities. Next slide, please. A recent study that was conducted in the Netherlands looked at how compostables were actually performing in compost facilities in the country. And 100% of the items that were looked at that study degraded in a timely manner. A similar study that was conducted in the US repeated the same results, but not only that, it confirmed that even adding 30% compostables into a pile of organic waste will still provide an A-grade compost quality. So hopefully such studies reduce a lot of the questions and skepticism by some recycling or compost facilities in terms of the practicality of using compostables in their sites. Next slide, please. While a lot of us may think of the collection of bio-waste and compostables as a way to get rid of food waste, actually compost is extremely important to assure the long-term fertility of soil. Soils globally are significantly degraded, with 33% of UK soils degraded, with an outlook that we only have arable land in the UK for the next 30 or 40 years. And compost brings extremely important value back into the soil. So not only compost is an excellent way to get rid of food waste, but it's also an extremely important nutrient for our soils in order for us to grow plants again. Next slide, please. So once we hopefully confirmed some of the properties and the added values of compostables, how can we integrate them now into our systems? Well, technology already exists. As Yoni and Julia presented, the entire report by SYSTEMIQ is only looking at available solutions, not at futuristic or potential solutions that may or may not enter the market. This is just a small selection of what TIPA is offering to the market and a small selection of some of the brands we work with in the UK. If we look at infrastructure in the UK, like the rest of Europe, mandatory collection from households of food waste will be mandated by 2023. So hopefully we have resolved that problem as well. Also, just to give you a glimpse of what that may mean, even if we tomorrow morning, for example, transfer all flexible packaging into compostables, that would be still only 6% of total food waste. And the entire plastic used today in the UK amounts to 20% of food waste. So what that eventually means is that, whereby if you want to now try to further advance technologies to recycle flexible plastic and need enormous investment to do that, with the integrating compostables into the organic waste collections is not going to require from us to add more capacity really for such a small percentage of the total volume. Next slide. In the UK, we already have today 53 authorized composting plants treating food waste, with over 20% of them already treating compostable packaging on a daily basis. So we have all of that already in place. And last but not least, it seems that the British consumers are actually already getting the message. They are starting to favor compostable over any other solution that there is out there in the market. So with that, we'll leave you some hopefully food for thought of how can we as an industry, anywhere from regulators to local authorities to the government, play a role in helping compostables enter as a mainstream solution to answer some of the huge challenges without plastic packaging. And that's it. Thank you very much.
Thank you, Julia. We got there, eh? So the technology worked in the end. That was great. A couple of questions from me, Julia. And firstly, you talked about the UK here, but of course we have an international audience. And what other markets around the world are you seeing particular uptake and interest in using compostable packaging where it can make sense with food waste collections?
Yeah, so first of all, any country that has signed the Plastic Pact is going there. Australia seems to be quite interested in compostable and in a very sincere way. One other thing that we're seeing is that the US market that has been quite dormant for us. I mean, TPI has been around for quite a few years and active in both in Europe and the US. There seems to be a real pickup of compostables now, and we hope that we will start seeing a lot more compostables in the US market within the next year or two. So quite big brands now are entering this space.
We see across Europe, and Julia Koskela mentioned this before, that there is some resistance from the composting plants to taking compostable packaging. And partly this resistance is, of course, because they don't want any packaging, because mostly what they're getting is plastic rather than compostables. Do you see that that mindset changing as compostables become more common on the marketplace?
Yeah, first of all, you have case studies. I mean, you look at Italy, where the inclusion of compostable packaging has been active for quite a few years. And actually, they've been able to reduce plastic contamination from 80% to 1.5%. So, and as one of the studies showcases, actually 49% or almost 50% of plastic waste in organic waste systems is derived from flexible plastic. So if you've removed flexibles and started to use compostables, then you've only helped reduce the problem versus augmenting it. Specifically with, now the UK going from 20% collection to 100%, that would just bring so much more plastic into eventually our soils. Compostables can have a real role to play in helping that plastic not be part of our soils.
Yeah, there's not just a pollution problem there, is there? There's also an economic problem. I spoke with the European Commission last week, and for you, Yoni and Julia, I estimated that the cost of transfer in funds from food waste collections to incineration with current plastic contamination levels is in the region of 2.5 billion euros a year once we start collecting food waste across the EU. Because that plastic cannot be composted and it cannot be digested for biogas. So it has to be taken out and sent to incineration. So it's not just a pollution problem, there's also a huge problem of transfer of funds into incineration and landfilling. And that's sort of, in a way, partly explains why a lot of the big waste companies are not particularly enthusiastic about food waste collection, because they run the incinerators. But would I be a cynic in saying that? Well, you're not going to answer. Do we have, Julia, any particular figures for the collection and processing of compostables here in the UK? I know we do in Italy, but do we have in the UK?
I think those are not yet publicly known. I mean, there are some specific companies that worry about the collection, mostly in closed loop arenas, but I'm not sure we have such data yet available.
Okay, and on the question of cost, you have all spoken about the cost of alternatives, including compostables, often being higher. Now, I know, Julia, for TIPA, that's not always an issue with its customers, is it?
Well, like we all understand, there's so much pressure now to do things differently that I think brands and retailers are obliged to act differently and to showcase their eventually consumers that they are trying to address the problem. So cost is not necessarily the biggest problem they're facing. It's their reputation, as Yoni said. It's their interest to be perceived as leaders in this market, picking up on these innovative solutions. So cost is not only, the only factor that goes into this.
Okay. The other issue that we've had, particularly in the United States, Julia, of SYSTEMIQ, is one around coating compostables with PFASs. And there's an issue there about potential contamination into food. Of course, that doesn't just regard compostables; it's also particularly paper and card. Have you found that is a barrier? Have you found that is an issue which people are raising as a barrier to using these new materials?
Absolutely, a lot of concern around PFAS. It's kind of the household name of chemicals to be concerned of, kind of on the most recent list. The companies we work with are really looking at that issue and having conversations with their suppliers, looking at what of our portfolio even has PFAS on it, how can we get out of it, what are the solutions, and testing alternatives, making sure that alternatives are found that actually work in the supply chain. So it sounds like it is a really pervasive contaminant right now, and one that we want to be moving away from. I don't know where legislation is on that issue, but certainly I'm seeing awareness and that being as part of all of these conversations.
Well, I think in the EU, most of those materials are now banned, have been banned in the last couple of years. There are still jurisdictions where that's not yet happened. Okay, I'm coming to the end of the questions that we have here. Some of these we will answer directly with some of the people who have sent in those questions. I always try to finish these webinars asking the speakers, are you optimists or are you pessimists? Is the glass half full or is the glass half empty? And if you are looking at a 10-year horizon, 2030, which is a horizon within which we must meet a lot of our targets, particularly on climate change, but also on waste. Do you see systemic change happening, or is it still a lot of talk? I'll be blunt.
I'm definitely an optimist. Working with companies day in, day out on reduction and substitution, I just feel like there's exponential innovation happening in this area. Customers, companies, board members, everyone is putting unprecedented effort into the area of circular materials in a way that I wish we had, had that speed of conversation with climate change 10, 20 years ago as we started talking about the conversation. Packaging has just really captured imaginations of everyone, and I think there's going to be fast change in this space. So I'm an optimist.
Just to build on that, I think you have to be an optimist to be in the space. I think some of the findings, and also what I heard today from TPA, but if I look at breaking the plastic wave, it definitely gives me optimism, because our key finding is that we have the solutions for 80% of the problem, right? That's massive, and that's definitely much more than we thought when we started. At the same time, we need to recognize that much more urgent change is needed, and that everybody really needs to play their part. Government, industry, innovation, investment, kind of the finance community, everyone. Then solutions are possible. So definitely optimist, but also let's make sure that we actually implement it. So also a bit of.
So before I go on to you, Julia, but I'm sorry, Yoni, I'm sorry not to agree with you. The massive amounts of new plastic capacity being put onto the market and being built now as we speak shows that the plastics producing industry is certainly considering that business as usual will carry on for quite some time.
Yes and no. Look, it's hard to argue with what you just said, right? There's $400 billion of commissioned new plastic capacity that we know of for the next 5 years. So it's hard to argue with that number. At the same time, just last month, we've seen, a $15 billion investment into new capacity being pulled out. I think there is a change happening. I think more and more investors are asking questions and are realizing that some of this investment may be stranded assets, maybe stranded capacity. We may be entering a plastic bubble, like we entered a carbon bubble. So people are asking questions. I fully agree with you, David. I wish the change were much faster, and we need a lot more urgency, and we need a lot more players. But I do think, I do see change starting. I think the speed, the direction of travel is the right one. The speed is definitely not the right one.
Julia?
Yeah, so at TIPA, first of all, we have to be optimistic. I mean, TIPA has been around from 2012, way before any of this data was even available to understand the magnitude of the problem of plastic. For us, it was just like, it doesn't make sense that a $102 billion industry is just completely non-recyclable. And so much has happened from that point of view to first of all, even acknowledging the problem. And the systemic report is probably the most comprehensive work as of today, acknowledging what's at stake from the one hand, and on the second hand, you look at the challenge to integrate compostables into our systems. They're so small eventually. I think it's the mindset that has to be changed more than anything else. I mean, infrastructure is here, technology is here. We can do all of that. We just have to decide that it's a valuable thing to do. Part of, I think, of the reason to have this webinar today is to hopefully convince more people that there's a role for compostables to play. And if we agree on that, then let's just do what needs to be done. And there's very little that actually needs to be done in order to get that into a realistic, practical solution.
Yeah, the barrier is not technology. The barrier is, as always, is money, and money drives the politics. So it's the politics that we have to work on to drive the money into the right direction. Okay, ladies and gentlemen, we've gone for more than an hour. We've had 3 great presentations from the 2 Julias and from Yoni. I'd like to thank them very, very much. On their slides, which will be distributed along with the video of this webinar, you will find their contact details so that you can ask them more specific questions. I'd like to thank Charles of Resource Media, who in the background has made this whole thing work and has got you all together. And thank you, ladies and gentlemen, for joining in. Hope to see you all again soon.